me see. Zach, how many questions did you manage to get done? 5? Yep. Diego?
1.
Harry?
2.
Lynn?
1.
Gina?
2.
Dorian?
1.
Great. 1 fully complete. That's fine. So you all got 1 question fully complete. That's good. So we'll start the next topic now. We're going to start on it. Can we look up? Or do you want to finish the question you're working on? No, it's okay. How do you pronounce this guy's name? Yeah, I don't know. Like I call him Kirchhoff, but I hear people call him Kirchhoff. This is Russian. Kirchhoff. Yeah, Kirchhoff. I don't know. It's a Russian name. You have seen it before or not? No? Whoever. Kirchhoff, I don't mind. So, Kirchhoff is like the Newton for electricity. Okay? So Newton, he has his 3 laws, and these are very important. And Kirchhoff has 2 laws for electricity, and these are very important for complicated problems. Again, it's one of those topics which high school students don't usually do. It's more of a university thing. Has anybody studied these laws before? You think maybe you have? What do you think, Gina? Have you seen Kirchhoff before? Not sure? You would remember a name like Kirchhoff, wouldn't you? Yeah. Anyways, let's have a look at what Kirchhoff has to say about circuits. So, Kirchhoff has 2 laws. Kirchhoff's first law. A body at rest will remain at... Oh no, wait, hang on. That's the other guy. Right, Kirchhoff's first law. It's also called the junction law. No, it's not that. It's not that. Kirchhoff's first law, the junction law, states that... Wait. I don't want you to write this down yet because I need to draw it before you write it down. At any junction or node in an electrical circuit, the sum of the currents flowing into that node is equal to the sum of the currents flowing out of that node. Let me explain what the heck Kirchhoff is saying here. So imagine you have some point in a circuit where maybe 3 currents come together and 1 comes out. And this one will say is I1, this one here is I2, this one here is I3, and this one here is I4, for example. Okay. What Kirchhoff said is I1 plus I2 plus I3 minus I4 equals 0. That's what he's saying. And the purpose of the plus or the minus is if it's going in or out. So can you see these 3 here are going into this junction, whereas this one is coming out. So that's why there's the minus there and the plus here. Okay. You realise though, if you move this to the right, you get a formula I gave you for the simple circuits, that the currents add. Okay. But Kirchhoff gives us this nice way of saying it, that the total current total is 0, provided that you call in plus and out minus. So mathematically you can write it as this formula. Have you seen this symbol here? What's it mean? So if you add all the currents, you should get 0, as long as in is plus and out is minus. Okay? Now before you write this down, the reason is, why is this law true? And this is due to what's called the conservation of charge. Okay? Which we haven't really talked about, but it kind of makes sense. Like if I have 2 coulombs that move through a circuit, at the end I still must have 2 coulombs. You can't delete charge, okay? It's very similar to what other law in physics? Conservation of energy. Right? You know this from chemistry. Like, electrons don't just suddenly disappear, do they? They might move in their orbits, or you could have them maybe, form a bond. But the electron doesn't just disappear. Okay? Now, In the exam, typically what they might say is, for like 2 marks, what is Kirchhoff's first law? So that's it there. And then for 1 mark, they would say, what is the reason for Kirchhoff's first law? And the answer is conservation of charge. Okay, so are you happy with this law? Okay, now carefully write this box down fully. Are you taking a picture because you can't see, or you need time? No, because there's no rush. There's no rush. I want you to write this down carefully. Oh no, I don't like coffee. I don't like this weather. It's making my head all stuffy. You got that all written down, Dorian? Yeah, good. Okay. So now that you've seen Kirchhoff's first law, what do you think? Have you seen this before? No. Zach?
Not like this.
Okay. Continue? Yes, Gina? Harry? Yep. I've already drawn this. Okay. Kirchhoff's second law, also called the loop law. So before you write it down, I would like to explain it first. But Kirchhoff's second law, the loop law, states that the directed sum of the voltage across a closed network is 0. So what the heck does that mean? Let me draw a picture for you. So if you have a circuit, whoa. Okay, there we go. Let's imagine this battery has E voltage, and this one here uses V1, this one here uses V2, and this one here uses V3. Okay. Kirchhoff says that E, if you start here and walk around the circuit in a loop, he said E minus V1 minus V2 minus V3 equals 0. Very similar. Again, this makes sense, doesn't it? Because the E here should equal V1 plus V2 plus V3. So we use plus to represent what?
The output.
Yeah, like providing. And minus?
Data.
Yeah, what's a fancier word?
Consuming.
Consuming, yeah, yeah. Also, I think you already know this, but what is the reason for this law? I mentioned it briefly once. Why is this law true? Remember what a volt is. What's a volt? A watt per watt. A coulomb per amp? No, you're just guessing now. A joule per coulomb. Remember? So now that you remember that volts are joules per coulomb, what is the reason for this law being true? conservation of energy makes it true, that the energy provided by the battery per coulomb must equal the energy consumed by the lights per coulomb. Right? You're nodding, but I'm not sure how much is being understood. All of it? Some of it? Most of it? Half of it? Yeah. Are we okay with this? Are we sure? Okay. So, what would be the formula? It would be, how would we write the formula? The sum, sigma, of all the voltages equals 0. Around a loop. Around a loop. Okay? This is due to the conservation of energy. Okay, write that down carefully.
So this can be used for both series and parallel?
Yeah. Yeah, this is why these laws are great. Oh, you guys make me worry sometimes about you. Oh, I'm hungry. I didn't have any dinner last night because my lunch was so big yesterday. I was too full to eat dinner.
What did you eat?
Oh, I had a kebab meal, and it was a big kebab, and it was a big bag of chips, and I was stuffed.
You use your...
I used my Uber Eats, yes. I got it from Barbecue Tonight. They're down by Passion for Food, I think. Is it? Or, no, what's it called? I don't know. Down by Clonbrassil Street, down that direction. Barbecue Tonight. They had like a meal, kebab, chips and a drink for €10. But really, if you were doing that, you would definitely need to share that with someone in your class. Because Sylvia got one, but she only ate half of it and saved half. Where I was thinking, no, I'll finish it. I'll do it. Probably shouldn't have. But anyways, I think it's a good deal if you want to split that with someone. You know, then it's €5 each. It's pretty good. It's pretty good. Okay, we got that written down. Yeah. So, I'm giving you some tips about Kirchhoff's rules. So, first tip. You don't have to write these down, or if you do write them down, you can just write down little parts of it. The first thing to say is, you can still use that VIR triangle, okay? We're not replacing it. In fact, you will need to use this still. So it is good to remember that you still have V equals IR. Okay? That's the first tip. Second tip. Generally, for most problems, you only need to use the junction rule once. Now, not always, but I often find in the exam, the questions they give you, you'll need to use the junction rule once. And often, I find that the loop rule, they have you use it twice in a question. Now, these aren't rules, it's just my tips. If the loop goes the wrong way through a battery or resistor, then the voltage flips sign. Now that's an important one. I think that's worth drawing on the side. I'll explain it here. So let's imagine you have some battery here. Which way is the current going? In this picture it's going to the left. Okay. If I use Kirchhoff's loop rule, what I do is I pick a point on the circuit and I go around the circuit and I add or subtract voltages as I go around, and the total should equal 0. That's Kirchhoff's loop rule, okay? But this loop is a little bit weird because when I get to the top, I'm moving the wrong way, haven't I? Like the current is going left, but I'm going right. So what that means is we imagine instead of getting a voltage, we subtract it. We're moving the wrong way. I'll give you another example too. Let's say here, let's keep it simple. Let's say this is 10 volts and this is 10 volts, okay? Kirchhoff says, if I move this way around, you would say plus 10 volts from this guy, minus 10 volts from this guy, that should equal 0, which it does, okay? But if I move the other way, if I start here, but move backwards, okay? This battery, we don't say it gives 10, I'm going the wrong way. Instead we say it takes 10. And then when I get to the light, I'm going the wrong way again. The current is going which way? To the left or to the right? To the right. But which way am I going? To the left. So instead of taking 10 volts, it gives 10 volts. And we get 0. Okay? So you need to be careful. If you're moving the wrong way, then the pluses become minuses and the minuses become pluses. You need to be careful with that. I had one student last year, and she did the Kirchhoff question 3 times, and she kept making a mistake, and I couldn't tell her what the mistake was. And the mistake she was making each time was she had the wrong sign on one of the... I can't remember exactly what the problem was. It was a problem. Anyways, it doesn't matter. Just be careful, please. Okay, so make note of this one. That's an important one. Okay, you can make some small note like wrong direction means change sign. You know, something like this. Okay. Right. Next point. You can choose any loop, however, it's easier to start with the cell and to go with the flow. I'll give you an example of what I mean. Okay, so imagine you have some really complicated circuit like this, or I don't know, something like that. Dun, 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 dun. So this goes here, maybe there's a light here, and then it connects up here, there's another light, but maybe there's another battery here, maybe there's another light here. So something like this, okay? How many loops can you choose? There's a loop here, 1. How many in total? 2 and 3. My tip is to always pick a loop that has a battery or a cell in it, and to start at that battery or cell, and to go in the direction of the battery or cell. So for example, if I start with this loop, do I start here, here, or here? I start at the top, yeah. And do I move left or right? Left. So the first loop should be this loop starting at the top. Okay. What the heck is that? Sorry. sorry. Okay, if I want to make a loop here, where do I start? Again here, and I should go top, down, across, and here. Okay. If you're in a situation where you have a loop like the outside but has 2 batteries in it, you should start at the bigger one. So let's say that this was 10 volts and this one was 5 volts, and I wanted to start on the out loop. I should start with the bigger battery. So I would start here and go left or right? Left, down, up and across. Okay, so
what happens with this battery?
Yeah, let's talk about that. Let me just say that this guy here uses, or we'll just say uses V1, V2, V3. Fine, okay. So let's make the outer loop. We start at the 10, plus or minus? Plus 10. And then what happens here? Minus V1. Now, what happens here? Is it plus 5 or minus 5? Well, the question is this. Is the battery the right way? remember, you need the positive to be with the negative for the voltages to add up. If it's the other way around, what happens? Reduces. So is it right or wrong? Right. So the effect of having this 5 will be a plus 5. And then here, minus V3 equal 0. So do you see what's going to happen with Kirchhoff? You're going to make many equations and solve them simultaneously, like in maths class. Yeah? What's wrong, Dorian? I think it's like you realised something and it made you sad. What is it? No? Continue? So you should make some note about that, please. Start with the biggest battery and go in the direction of the current is my advice. Got something written about that? Yeah? So look, I think this wraps a nice point to finish, because what I was going to do next is use Kirchhoff laws for this problem, which we've done already. We'll discover using Kirchhoff makes this a lot easier to do. Okay? And then we'll have a look at some exam questions. Like this fella, or like this fella, or like this fella, or like this fella. They look worse than they are. Now, before I finish, please note, in the workbook, there is only one Kirchhoff question. This is not because Kirchhoff is not important for the exam. It is because Kirchhoff is usually so big, it's only in section B. Okay? It's very rare to have it in section A as a short question. It's only happened once. So this is why I have a few questions for us to practice in class. Because this is a section B question. It's worth 10%. Another section B worth 10%. Another section B worth 10%. It usually goes 3, 3, 3, 1 marks. This is a question I got from the book, but it's like a section B question. But I like this one as practice in class. And this is one we've done already. Okay, so we'll need at least another hour to do these 1, 2, 3, 4, 5 examples. Okay, and then you have one to practice at home after that. Okay, so look, the only homework from today is the RC, but tomorrow bring your laptop. We'll be looking at essay introduction, I think. Okay, are you okay, Gina? Yeah, all right. Time for lunch or more class? Oh no! What class?